This video will present a massively parallel AI cluster for a new AI algorithm called the Tsetlin Machine. Our cluster is made from embedded boards, and we will give a short overview of the system, a demo of its functionality, and finally some explanation into the real-time power analysis. Our system is composed of 18 system-on-chip ODROIDs which have both CPUs and GPUs together on the same chip and are connected through a switch. The front-facing user can access the cluster through a front-end interface where they can submit their own data and see the real-time analysis. And this is done through connecting our cluster through a workload host PC and using OpenCL to distribute work on both the CPUs and the GPUs on each node. Our cluster also has custom power measuring modules on each of the nodes so that we can monitor the real-time power efficiency. Now we're going to perform a short demo of the backend where we are distributing some workload and we are monitoring the real-time power consumption of 7 of the nodes. And we're going to see the real-time learning as we print some of the training results. So you can see here we've selected some of the data points from our training example, and we see that as we go through the number of epochs, our average accuracy starts to increase. And we can see that as the number of examples that we get wrong will start to decrease each time. Now, if we focus on the diagram on the right, we will see that the way the cluster works is that we select one host node who will contain all of the important information. He will distribute it across all of the other clusters. They will perform the workload and only reconvene with the host when it's required. Otherwise, they will perform their tasks in a distributed way. So you can see here we ended on an accuracy of 80. This will obviously continue for the number of epochs that the user has set. Right, so now if we focus on one of the ODROIDs, you can see we're showing the multi-threaded nature of our work. So we have the Backend Demo program. You can see multiple threads of that running, and you can also see the CPU utilization for it as well. So now we will show how a front-end user might submit data to the cluster. So we have a home page like this where the user can enter the requirements such as the features, the hyperparameters, the classes, the clauses, and the epochs. They can also select how they'd like to distribute, so the CPU or the GPU or both, and they can submit their data as CSV files as well. Now this data will be sent directly to the cluster and it will be distributed according to how we see fit. We've deliberately made the convergence slower so we'll be able to see it as a real-time plot of performance. We're also showing the power consumption here, but for now this is dummy data and we will connect the actual power module very shortly. So this concludes the front end of the Tsetlin machine, and now I will pass over to Jie, who will discuss the power efficiency measuring circuitry that was built custom for the cluster.
In order to measure the power efficiency of our cluster, we built 18-channel external power analyzer for each of the ODROID. The ODROID is powered by the DC power supply. The DC will pass through a precision power monitoring IC in order to measure the voltage and current consumed by the ODROID. This information will also be fed into the microcontroller, and the microcontroller is connected to PC to report the real-time power consumption of each ODROID. As you can see in the figure 1 in the left corner, we're measuring 7 ODROID and how much energy they consume. We can measure this information in real time and log it into our file system. And thank you for your attention. I hope we can see each other again. Thank you.